Dr. Muhammad Hadir bin Maslan. We are from Bmmv Section 1 students. Today we are going to present on topic pump system for marine technology system subject. I would like to introduce myself first. Myself, Yuvadarshni Jaykumaran, metric number B0918103553. And then Muhammad Nakiruddin bin Suni, metric number B0918109291. Then followed by Amir Aziz bin Wahab Ghaffar, metric number B0918104663. Muhammad Putra Arianto bin Bahari, metric number B0918102216. And the last team member, Muhammad Afiq Izzah Ahmad Isman, metric number B0918105336. Okay, this is the picture of basic pump system. Next. Okay, this presentation going to be based on this layout. First one, introduction of the pump system, followed by classification, types of pump, and also its operation flow, working principle, some simple calculation on pump analysis, and also the last part is conclusion. Okay, for the first part, introduction of the pump system. A pump is a mechanical device that uses to transfer different fluid from one location, one place to another place. It is a hydraulic device that lifts the fluid from low to high levels, move fluids from low to high pressure areas. The pump transfer fluid by converting the fluid's mechanical energy into pressure energy we can identify as a hydraulic energy. Marine pumps can be serviced for cooling, circulating ballast, general service, firefighting, boiler feed water, condensed water, fresh for drinking water, sanitary water, bilge sludge, FO transfer, LO transfer, FO and FOs, cargo pumping, cargo striping, hydrophone tank unit, sewage treatment, oil water separator, incinerator, freshwater generator, and much more. Okay, I will pass the next part to my group member Amir Aziz to continue this present.
Okay, thank you. For the classification of pump system, in pump we can divide to two, which is dynamic and positive displacement. For the dynamic, we have centrifugal and special effect. Which centrifugal is axial flow, mixed flow, and peripheral. So for the side effect, we have jet and electromagnetic. For the positive displacement, we also have two, which is reciprocating and rotary. In reciprocating, we have piston and plunger, and also have diaphragm. For the rotary, we have single rotor and multiple rotor.
This is type of pump and pump operation flow. For here have two type of pump. First of all is dynamic pump that separate by three: centrifugal pump, vertical centrifugal pump, and horizontal centrifugal pump.
And the positive displacement pump, which is diaphragm, gear, and piston.
For centrifugal pump, this pump is strong, efficient, and fairly cheap to make. Whenever the pump is in action, then the fluid pressure will increase from the inlet of the pump to its outlet. The change of pressure will drive the fluid throughout the system. This kind of pump produces an enhancement which is forced by transmitted mechanical power from the electrical motor to the liquid throughout the revolving impeller. The flow of liquid will enter the center of impeller and exist along with its blades. The centrifugal power hereby enhance the velocity of fluid, and also the energy like kinetic can be altered to force. The second one is vertical centrifugal pump. Vertical turbine pump work when water enter the pump at the bottom through a bell-shaped part called the suction bell. From there, it moves into the first stage impeller, which rise the water velocity. The water then enter the diffuser bowl immediately above the impeller, where this high velocity energy is converted into high pressure. The ball also directs the fluid into the next impeller located immediately above the bowl. And this process continues through all of the stage of the pump. And the last one for dynamic pump is horizontal centrifugal pump. The impeller, which is connected to the electric motor through the shaft, start rotating. Due to the rotation of the impeller, a vacuum creates inside the eyes of the impeller. Hence, the liquid below the suction pipe begin to enter inside the impeller eyes in the axial direction. After entering the impeller eyes, the liquid strike the vanes of the impeller. The high speed of the impeller rotates the liquid radially and in a outward direction by using centrifugal force. The impeller keeps on rotating until the liquid passes through every component of the impeller. The rotating accelerates the fluid, which increases the fluid energy and creates the fluid head.
Okay, for the positive displacement pump, first is the diaphragm pump. Diaphragm pump is a double diaphragm is a positive displacement pump which utilize two flexible diaphragms that reciprocate back and forth, creating a temporary chamber which both draws in and expels fluid through the pump. The diaphragm works as a separation wall between the air and the liquid. Then the second is the gear pump. The gear pump working principle is it uses the gear actions, otherwise rotating action to move liquids. The rotating part extends the seal of liquid by the pump case to create suction at the inlet of the pump. Liquid drawn into the pump can be included in the rotating gears cavities and moved to the expulsion. And the third pump is the piston pump. This pump include more than one piston with a set of control device. The duplex pump includes two pistons as well as two controlling device. Similarly, a triplex pump includes three pistons as well as three controlling device. It is very important to check the controlling device on both sides to ensure that the flow of liquid direction at both sides is flowing or not. These pumps are single, otherwise double acting pumps. Double acting pump involves two set of controlling device and liquid on both ends. This lets the pump to complete a pumping cycle by flowing in one direction to other. When the piston is taking in one direction, then it will exhaust at another side. This pump needs solo action versions for flowing in both direction for completing a cycle.
Okay, next calculation on pump analysis. The performance of a pump is a function of the precision of its manufacture. An ideal pump is one having zero clearance between all mating parts. Because this is not possible, working clearance should be as small as possible while maintaining proper oil films for lubrication between rubbing parts. The performance of a pump is determined by the following efficiencies. The first one is volumetric efficiency. It is the ratio of actual flow rate of the pump to the theoretical flow rate of the pump. The formula for volumetric efficiency is actual flow rate of the pump over theoretical flow rate of the pump. The second one is volumetric efficiency indicates the amount of leakage that takes place within the pump. This due to the manufacturer tolerance and flexing of the pump casing under design pressure operation condition. The gear pump tolerance is between 80% to 90%. For vent pumps, equal to 92%, and for the piston pumps, it is 90% to 98%. The second is mechanical efficiency. It is the ratio of the pump output power assuming no leakage to actual power delivered to the pump. The formula for mechanical efficiency is pump output power assuming no leakage over actual power delivered to the pump. Okay, mechanical efficiency indicate the amount of energy losses that occur for reason other than leakage. This includes friction in bearing between the mating parts. This includes the energy losses due to the turbulence. Mechanical efficiency are about 90% to 95%. We have the relation. This is the formula where P is the pump discharge pressure in Newton over meter square. Q is the theoretical flow rate of the pump. TA is the actual torque delivered to the pump, and N is the speed of the pump. Below is the formula for the theoretical. Below is the formula. Okay, next. The theoretical torque required to operate the pump is the torque that would be required if there were no leakage. The theoretical torque is determined as follows. Okay, and lastly, overall efficiency. It is defined as ratio of actual power delivered by pump to actual power delivered to the pump. The formula is actual power delivered by pump over actual power delivered to the pump. Okay, next.
Okay, let me take for the example 1. Yeah. Okay, the question is, what is the theoretical flow rate from a fixed displacement axial piston pump with a 9-bore cylinder operating at 2000 RPM? Each bore has a diameter of 50 millimeters and stroke is 20 millimeters. Okay, let me see. The theoretical flow rate is given by, for the formula is QT equal volume times RPM times number of piston. Okay, then we calculate the volume. The formula is pi over 4 times diameter square times length, and N is the RPM and the N number of piston. Okay, for the next example, okay. A gear pump has an outside diameter of 82.6 millimeter, inside diameter of 57.2 millimeter, and a width of 25.4 millimeter. If the actual pump flow is 1,800 RPM and the rate pressure is 0.00183, what is the volumetric efficiency? The solution is we have the outside diameter is 82.6 millimeter and inside diameter 57.2 millimeter, and the width is 25.4 millimeter. Speed of pump is 1,800 RPM. Actual flow rate is 0.00183 meter cube per second. And first we calculate the theoretical flow rate. Its formula is QT pi over 4 times diameter outside diameter minus inside diameter times d and times n over 60. Then we calculate the volumetric efficiency and you get the answer 86.11%.
Okay, for the conclusion, we can define that many piping systems are not well designed or controlled. Your ability to determine pump performance or reliability is highly depend on your knowledge of pump root dynamic. So centrifugal pump should be selected and normally operate at or near the manufacturer design rate condition of head and flow. For the pumping system performance, efficient, reliability are highly influenced by the system they supply. Component failure are often caused by the system problem, system design, specification, installation, and operation. Operator need to understand the symptom that occur the the system when it's operate away from the best efficiency point. We should remember that efficiency and reliability go together. Take a system approach when evaluating of your repair and maintenance option. And I think that's all from our group. Thank you.
Thank you.
Thank you.